Welcome to our comprehensive study of Indian geography. Let us begin by looking at India as a geographical unit. India lies entirely within the northern hemisphere. If we look at the massive continent of Asia, India is situated right in the south-central portion. It is prominently bordered by the Indian Ocean to the south, with its two major arms flanking the peninsula, the Bay of Bengal to the east and the Arabian Sea to the west. When we examine the mainland of India, we see a vast expanse of territory. From the northernmost mountainous regions of Ladakh, the mainland stretches all the way down to the coastal town of Kanyakumari in the deep south. Looking from east to west, the mainland spans from the eastern frontiers of Arunachal Pradesh across the subcontinent to the western state of Gujarat. India's sovereignty extends beyond its physical landmass. Its territorial limit reaches out into the sea up to 12 nautical miles, which is roughly 21.9 kilometers from the coast. While Kanyakumari is the southernmost point of the mainland, the absolute southernmost point of the entire country is Pygmalion Point, also known as Indira Point, located in the Andaman and Nicobar Islands at 6 degrees 45 minutes north latitude. Unfortunately, this specific geographic point was submerged under seawater during the devastating Indian Ocean tsunami in 2004. Let us look at the precise measurements of this vast country. The physical distance from the northernmost part of Ladakh to Kanyakumari is 3,214 kilometers. The distance from the Run of Kutch in the west to Arunachal Pradesh in the east is 2,933 kilometers. Interestingly, if we look at the coordinates, the east-west extent is roughly 30 degrees and the north-south extent is also roughly 30 degrees. You might be wondering why both extents are about 30 degrees, yet the north-to-south distance is significantly longer than the east-to-west distance. This happens because of the geoid shape of the Earth. The distance between any two lines of longitude decreases as you move away from the equator towards the poles, eventually becoming zero at the poles. However, the distance between any two lines of latitude remains practically the same everywhere, at roughly 111 kilometers. Therefore, the east-west physical distance shrinks as we move north of the equator. This data provides a clear summary of India's geographical boundaries. You can see the extreme coordinates marking the edges of the country. Notice the extensive coastline, which measures a massive 7,516.6 kilometers, including the island territories. India also shares land borders with 7 countries. The longest international boundary is shared with Bangladesh at over 4,096 kilometers, followed by China and Pakistan. The shortest border is with Afghanistan at just 106 kilometers. Let us test our understanding with a past examination question from the year 2000. The question asks, along which one of the following meridians did India experience the first light of the sunrise of the new millennium? The options are 82 degrees 30 minutes west, 82 degrees 30 minutes east, 92 degrees 30 minutes west, or 92 degrees 30 minutes east. Take a moment to consider how longitude relates to sunrise. The correct answer is D, 92 degrees 30 minutes east. Here is the reasoning. The Earth rotates from west to east, which means sunrise always occurs first in the east. Because India is located entirely in the eastern hemisphere, we only need to consider the eastern longitudes. Since longitude values increase as you move further east from the prime meridian, the highest eastern longitude will experience sunrise first. Among the given choices, 92 degrees 30 minutes east is the furthest east. Here is another question, this one from 2015. Which one of the following pairs of states of India indicates the easternmost and westernmost state? The options are A, Assam and Rajasthan, B, Arunachal Pradesh and Rajasthan, C, Assam and Gujarat, or D, Arunachal Pradesh and Gujarat. Think back to our discussion on the east-west extent of the mainland. The correct answer is D. Arunachal Pradesh is the easternmost state of India. It shares international borders with Bhutan, China, and Myanmar, and its easternmost point is a town called Kibathu, located at 97 degrees 25 minutes east longitude. On the opposite side, Gujarat is the westernmost state, bordering Pakistan and the Arabian Sea. Its westernmost point is Sur Creek, situated at 68 degrees 7 minutes east longitude. Moving beyond just the national borders of India, we must discuss the broader region known as the Indian subcontinent. This distinct landmass comprises 5 countries: Pakistan, Nepal, Bhutan, Bangladesh, and India. The defining feature of this subcontinent is the mighty Himalayan mountain range. The Himalayas stand like a massive fortress wall, isolating the subcontinent from Central and East Asia. But they are not just a physical barrier. They fundamentally divide the climate, the river drainage systems, and the cultural evolution of the region, giving the subcontinent a highly distinct regional identity. This brings us to a descriptive question from the 2021 examination. Why is India considered as a subcontinent? Elaborate your answer. To answer this comprehensively, we must look at several key factors that elevate India from a mere country to a subcontinental entity. These factors include its massive size, its distinct geographical boundaries, its unique geological history, its incredibly diverse cultural heritage, and its significant political and economic influence in the region. Let us break down each of these factors. First, we look at geography. India is geographically massive, covering an area of over 3.2 million kilometers. This sheer size alone makes it significantly larger than most other countries in the world. Furthermore, its geography is highly distinct and self-contained. The towering Himalayas in the north act as an impenetrable natural barrier. Down south, the landscape shifts dramatically to the ancient Deccan Plateau, which is flanked by lush coastal plains on both sides. This geographical isolation and variety are classic hallmarks of a subcontinent. Next is its geological history. India was not always attached to Asia. Millions of years ago, the Indian landmass was actually part of a massive southern supercontinent called Gondwana, alongside Australia, Africa, and Antarctica. It eventually broke off and drifted northward across the ocean before colliding with the Eurasian plate. This incredible tectonic journey resulted in highly unique geological formations and allowed a very distinct biodiversity to evolve in isolation before the collision. Another defining characteristic of a subcontinent is immense diversity, and India boasts a rich tapestry of it. The region is home to thousands of distinct cultures, languages, religions, and ancient traditions. This incredible variety is woven into everyday life, clearly visible in the regional cuisines, vibrant festivals, traditional clothing, and stunning architecture. The peaceful coexistence of so many distinct ethnic groups within its borders mirrors the complexity usually found across an entire continent rather than a single country. Historically, India has a long and complex narrative that spans thousands of years. It has been the cradle for some of the world's oldest and most advanced ancient civilizations, such as the Harappan and the Vedic civilizations. Over the millennia, it has served as a crucible for massive, continent-spanning empires, including the Mauryan, Gupta, Mughal, and eventually the British Empire. This deep, layered historical legacy has profoundly shaped the identity of India as a distinct subcontinental sphere of influence. Finally, we must consider the aspect of unity. Despite the immense cultural, geographic, and linguistic diversity we just discussed, India has managed to maintain political unity for significant portions of its history. Since gaining independence from British rule in 1947, India has successfully remained a single, unified nation-state. It achieves this by utilizing a federal governance structure, which allows regional autonomy to accommodate its vast diversity while maintaining a strong central union. We will explore how this strategic location impacts its global standing in our next segment. Picking up right where we left off with India's geography, let's examine its physical frontiers. India is a massive country, and its borders reflect that scale. It has a land border stretching over 15,000 kilometers, weaving through 16 states and 2 union territories. On the maritime front, India boasts a coastline of over 7,500 kilometers. This includes both the 6,100 kilometers of the mainland and the extensive coastlines of its island territories. Let's break down that coastline, as this is a frequent point of testing in exams like the UPSC. Exactly 9 states share the coastline. On the west coast, we have Gujarat, Maharashtra, Goa, Karnataka, and Kerala. Moving to the east coast, we find Tamil Nadu, Andhra Pradesh, Odisha, and West Bengal. Additionally, 4 union territories have coastlines: Lakshadweep and the combined Daman and Diu territory in the Arabian Sea, plus Puducherry and the Andaman and Nicobar Islands in the Bay of Bengal. Because India has such extensive borders and coastlines, almost every state is a frontline state in terms of border management. However, there are a few exceptions. If we look inland, only 5 states, Telangana, Madhya Pradesh, Chhattisgarh, Jharkhand, and Haryana, along with the Union Territory of Delhi, are completely landlocked without any international borders or coastlines. Now, looking at India's immediate neighbors, you might be surprised by who shares the longest border. It isn't China or Pakistan. India's longest land border is actually with Bangladesh, stretching over 4,096 kilometers. Conversely, the shortest border is a brief 106-kilometer stretch with Afghanistan in the Ladakh region. Here's the complete breakdown of India's land borders ranked by length. After Bangladesh, China is second at 3,488 kilometers, followed closely by Pakistan. Then we have Nepal, Myanmar, Bhutan, and finally Afghanistan. Notice how many states and union territories are involved in managing these borders. It requires massive logistical and security coordination across diverse terrains. Let's dive deeper into the border with China, known as the Line of Actual Control, or LAC. This border is highly complex and heavily disputed. In fact, the two countries don't even agree on its length. India considers the LAC to be 3,488 kilometers long, while China claims it is only around 2,000 kilometers. This massive discrepancy is the root of ongoing geopolitical tensions. To understand why there is a dispute, we have to look at British colonial history. In 1865, the Johnson Line was proposed, which placed the Oxide Chin region firmly inside India. India considers this the correct, rightful national border. However, in 1893, the Macdonald Line was proposed, which placed Oxide Chin under Chinese control. Naturally, China considers the Macdonald Line to be the correct border. The eastern part of the border has its own history. In 1914, the Shimla Agreement established the McMahon Line between British India and Tibet. However, China rejected this. The situation escalated in 1950 when China annexed Tibet. Following this, Mao Zedong introduced the Five Fingers of Tibet theory, claiming that Tibet was China's right hand and Ladakh, Nepal, Sikkim, Bhutan, and Arunachal Pradesh were its five fingers, implying a claim over all these territories. These historical disagreements eventually boiled over. In 1957, China occupied Oxide Chin. Intermittent clashes followed until October 1962, when China launched a full-scale invasion into Ladakh and across the McMahon Line in Arunachal Pradesh. After a month of war, China declared a ceasefire, having secured control of Oxide Chin. The boundary that existed after the troops settled became known as the Line of Actual Control. It is crucial to distinguish between the LAC with China and the LOC with Pakistan. The Line of Control, or LOC, is a legally recognized boundary resulting from a 1948 UN ceasefire and formalized in the 1972 Shimla Agreement. It is drawn on a map signed by both militaries. The LAC, on the other hand, is merely a concept. It is not mutually agreed upon, not drawn on a shared map, and not physically demarcated on the ground. Because of its vast length and varied geography, the Line of Actual Control is divided into three distinct sectors for military and administrative purposes: the western sector in Ladakh, the middle sector covering Uttarakhand and Himachal Pradesh, and the eastern sector spanning Arunachal Pradesh and Sikkim. Let's look at the western sector, which separates Ladakh from China's Xinjiang province. India claims the entire Oxide Chin region, based on the Johnson Line, as well as the Shoksgam Valley, which Pakistan illegally gifted to China. China, meanwhile, contests Indian control over strategic areas like Dolet Beg Oldi, which is vital because it hosts the world's highest airstrip. Also in the western sector is the famous Pangong Tso Lake. Situated at over 4,200 meters, this landlocked saline lake is 135 kilometers long. India controls about one-third of it, while China controls the rest. While the lake itself isn't a military base, it is highly strategic because it lies directly in the path of the Chushula Couch, a key route China could use for an offensive into Indian territory. Moving to the middle sector, covering Uttarakhand and Himachal Pradesh, things are relatively calmer. In fact, this is the only sector along the entire Sino-Indian border where the two countries have actually exchanged maps and broadly agreed on the boundary alignments. The eastern sector runs from Bhutan all the way to the Diffu Pass, which is a tri-junction between India, Tibet, and Myanmar. Here, the dispute centers entirely on the McMahon Line. India controls the territory south of this line, which is the state of Arunachal Pradesh. However, China refuses to accept the McMahon Line and formally claims Arunachal Pradesh as its own territory, referring to it as South Tibet. Seriously, a major flashpoint in this region is the Doklam Plateau. Doklam is located at the tri-junction of India, China, and Bhutan. While the territorial dispute is technically between Bhutan and China, India is deeply involved. Why? Because Doklam is dangerously close to India's Siliguri Corridor, also known as the Chicken's Neck, a narrow strip of land that connects the northeastern states to the rest of the Indian mainland. Any Chinese advance here is a massive security threat to India. Shifting our focus to the west, we have the Indo-Pakistan boundary. This border was drawn up in 1947 under the Radcliffe Award during the partition of India. The most significant and volatile disputed regions along this border are Jammu and Kashmir in the north and the Sur Creek estuary down in the Kutch region of Gujarat. Within the Kashmir dispute, we must highlight Gilgit-Baltistan and what Pakistan calls Azad Kashmir. Interestingly, while Pakistan administers these areas directly from Islamabad, they are not officially recognized as provinces in Pakistan's constitution. India's stance is absolute. A 1994 parliamentary resolution declares both regions as integral parts of the Indian state of Jammu and Kashmir. The situation is further complicated by the China-Pakistan economic corridor running through this territory and Pakistan's illegal gifting of the Shaksgam Valley to China in 1963. Looking at our other neighbors, the India-Nepal boundary stretches for 1,751 kilometers, mostly running along the foothills of the Shuwalik Range. It touches 5 Indian states. Unlike the heavily militarized borders with China and Pakistan, the Nepal border is porous, allowing for the unrestricted movement of goods and people, reflecting deep cultural and economic ties. As mentioned earlier, the India-Bangladesh border is India's longest at over 4,000 kilometers. Like the Pakistan border, this was also determined by the Radcliffe Award in 1947, which divided the historical province of Bengal. This complex, winding border touches 5 Indian states and features numerous riverine boundaries. To the far east, the India-Myanmar boundary runs for 1,643 kilometers. It naturally follows the watershed between the Brahmaputra and Irrawaddy rivers, passing through incredibly dense forests and rugged hills. Due to security concerns, the Indian government has recently decided to construct a fence along this entire stretch. Finally, looking south into the Indian Ocean, we have our maritime boundary with the island nation of Sri Lanka. The two countries are separated by the Gulf of Mannar and the shallow waters of the Palk Strait. At their closest point, India's Dhanishkodi is merely 32 kilometers away from Sri Lanka, connected by the chain of limestone shoals known as Rama Setu. Understanding these diverse and complex frontiers sets the stage perfectly for our next topic, which leads us perfectly into the major geological and physical divisions of India, which we will map out next. Let's examine the major geological and physical divisions of India. India can be broadly divided into 5 distinct physiographic regions. First, we have the Himalayas, which are young fold mountains. Second is the Indo-Gangetic Plain, characterized by a monotonous, featureless topography, and this actually includes the Thar Desert. Third is the Peninsular Plateau, recognized as one of the most stable landmasses and oldest plateaus in the world. Fourth are the coastal plains, formed by sedimentation due to fluvial action. Finally, we have the Indian Islands, which include coral islands like Lakshadweep built on atolls, and tectonic islands like the Andaman and Nicobar Islands, formed by the interaction between the Indian and Eurasian tectonic plates. Looking at the extent of different topographies across the country, we see a diverse landscape. Plains make up the largest portion, at 43%. Mountains, specifically areas more than 2,135 meters above sea level, account for 10.7%. Hilly areas, ranging from 305 to 2,135 meters, cover 18.6%. Lastly, plateaus, sitting between 305 and 915 meters above sea level, make up 27.7% of India's landmass. Each of these divisions possesses unique geological features and resources based on its underlying structure. For example, the Peninsular Plateau is incredibly rich in minerals, such as iron ore, manganese, and mica. The Himalayas are home to crucial glaciers, snow-capped peaks, and deep valleys. Meanwhile, the Indo-Gangetic Plain is renowned for its highly fertile soil, driving agricultural productivity. Together, these geological divisions play a crucial role in shaping India's topography, climate, and natural resources, directly influencing the region's socioeconomic development. Moving on to the geological history of India, the rock systems can be classified into 4 primary types. These are the Archean rock system, the Purana rock system, the Dravidian rock system, and the Aryan rock system. We will explore each of these in detail to understand how India's landmass evolved over billions of years. The first is the Archean rock system, which consists of Precambrian rocks. Formed prior to the Cambrian system, these are the absolute oldest rocks found in India. They are predominantly located in the Peninsular Shield and are composed primarily of igneous and metamorphic rocks. Within the Archean system, we have the Archean gneisses and schifts, dating back a staggering 4 billion years. Gneiss has a mineral composition varying from granite to gabbro, while schist are mostly crystalline, containing minerals like mica and talc. Formed by the cooling of molten magma when the Earth's surface was scorching hot, they are known as the basement complex because they form the foundational base for all newer layers. They are azoic, meaning they contain no fossils, and are thoroughly crystalline due to their volcanic origin. Also part of the Archean era is the Darwar system, ranging from 4 billion to 1 billion years old. These are highly metamorphosed sedimentary systems, formed from the sediments of the older Archean gneisses and schists. Economically, these are the most important rocks in India because they hold incredibly valuable minerals, including high-grade iron ore, manganese, copper, lead, and even gold. They are abundantly found in the Darwar district of Karnataka and spread across central and eastern India. Next is the Purana rock system, dating back 1,400 to 600 million years. These rocks indicate varied geological processes, featuring a mix of sedimentary rocks like sandstones, volcanic rocks like basalts, and metamorphic rocks like marble. Located mainly in the peninsular shield and parts of the Himalayas, the Purana system is divided into two main categories, the Kadapa system and the Vindhyan system. The first division, the Kadapa system, was formed by the deposition of unfossiliferous clay, slates, sandstones, and limestones in synclinal basins, which are essentially depressions between two folds. Best observed in the Kadapa district of Andhra Pradesh, these rocks contain vital ores of iron, manganese, copper, and nickel, along with massive deposits of cement-grade limestones. The second division is the Vindhyan system, named after the Vindhyan Mountains. This system comprises ancient sedimentary rocks up to 4,000 meters thick, sitting right on top of the Archean base. While it is devoid of metalliferous minerals, it is highly famous for its diamond-bearing regions, from which the legendary Panna and Golconda diamonds were mined. It also provides vast quantities of durable building stones, ornamental stones, and pure glass-making sand. The third major classification is the Dravidian rock system, formed during the Paleozoic era, about 600 to 300 million years ago. Interestingly, despite the name Dravidian, these rocks are very rare in South India. They are mostly found in the extra-peninsular region, like the Himalayas and Ganga Plain. Unlike the older systems, these are sedimentary rocks with abundant fossils, covering periods from the Cambrian up to the Carboniferous. A significant part of the Dravidian system is the Carboniferous rocks, dating back 350 million years. These comprise mainly limestone, shale, and quartzite. In fact, Mount Everest is composed of upper Carboniferous limestones. Globally, this age is famous because coal formation started here. However, it is important to note that most of the coal found in India is not from this period, which is why Indian coal is generally of poorer quality compared to the older Carboniferous coal found in the US or UK. Finally, we reach the Archean rock system, which is geologically recent, spanning from about 400 million years ago to the present day. This system is incredibly diverse in its locations, encompassing the Himalayas, Gondwana basins, Deccan Traps, and our modern alluvial plains. It includes a wide variety of sedimentary deposits as well as significant volcanic rocks. A major component of the Archean system is the Gondwana system, named after the Gond tribes. These deposits were laid down in synclinal troughs on ancient plateau surfaces. As the troughs subsided under the weight of sediments, freshwater gathered and terrestrial plants and animals thrived, starting around 250 million years ago. Found in river valleys like Damodar and Mahanadi, these rocks hold rich deposits of iron ore, copper, uranium, and antimony. The Gondwana rocks are incredibly important economically because they contain nearly 98% of India's coal reserves. Because this coal is much younger than Carboniferous coal, its carbon content is relatively low. This exact point was tested in a 2010 UPSC exam, which asked why Gondwana rocks are considered the most important rock system in India. The correct answer is that more than 90% of India's coal reserves are found within them, making them a major source of energy for the country's economy. Moving forward in time within the Archean system, we have the Triassic and Jurassic systems. India's Triassic system is mainly concentrated in the Himalayan belt, while the peninsular shield lacks exposure because it remained a stable landmass. During the Jurassic period, sea levels rose in a process called marine transgression, giving rise to thick, shallow water deposits in Rajasthan and Kutch, leaving behind coral limestone and sandstones. Following the Jurassic is the Cretaceous system, spanning from 145 to 66 million years ago. This system is widely distributed across both the peninsular and Himalayan regions. It consists of a diverse variety of rocks that were deposited across different environments, including dry land, sea estuaries, and lakes. A monumental geological event that began at the end of the Cretaceous period was the formation of the Deccan Traps. Massive outbursts of basaltic lava erupted from fissures due to hotspot volcanism, originally covering a vast area of 1 million square kilometers. These volcanic deposits have flat tops and steep sides, earning them the name traps, which means stair or step in Swedish. Over millions of years, the weathering of these basaltic rocks has given birth to the highly fertile black cotton soil, also known. The Deccan Traps are divided into 3 distinct groups based on their geological characteristics. The upper trap, found in Maharashtra and Saurashtra, features both intertrapen beds and layers of volcanic ash. The middle trap, located in central India, has volcanic ash but rarely any intertrapen beds. Conversely, the lower trap in Madhya Pradesh contains intertrapen beds but almost no volcanic ash. You might be wondering what exactly intertrapian beds are. During basaltic volcanism, lava flows out, cools, and solidifies. Over time, normal sediments settle on top of this cooled rock. Later, another volcanic eruption covers that sediment layer with more basalt. These successive layers of trapped sediments, sandwiched between layers of hard basalt, are what geologists call intertrapian beds. Next is the Tertiary system, spanning from 60 to 7 million years ago, often referred to as the Age of Mammals. This is arguably the most significant period in India's geological history. It was during this time that the Himalayas were born, and the Indian subcontinent, as we recognize it today, finally took its present form. The Tertiary period saw dramatic tectonic shifts. During the Eocene epoch, 60 million years ago, India initiated its massive collision with the Eurasian plate. Moving into the Oligocene and Lower Maionian, this collision caused the uplift of the Tibetan Plateau and the gradual towering emergence of the Himalayas. Later, the Shiwalik system formed from thick sedimentary deposits in the growing Himalayan basin, trapping countless fossils that give us deep insights into the evolution of mammalian life. Finally, we arrive at the Pleistocene system, part of the Quaternary period, dating from 2.6 million to about 11,700 years ago. This era is heavily characterized by multiple glacial and interglacial cycles. During this time, massive glacial features carved out the Himalayan region, while vast alluvial plains were deposited across the Indo-Gangetic Plain. Additionally, wind-blown loess deposits enriched the soils in regions like Punjab and Haryana. Let's look at a past exam question from 1997 that tests our understanding of these geological timelines. We need to match formations with their eras. The Deccan Traps were formed during the Cretaceous to Eocene periods. The Western Ghats underwent significant processes in the late Cenozoic. The Aravalli Range is one of the oldest, forming in the Precambrian. And the Narmada-Tapi alluvial deposits are recent, from the Pleistocene. Therefore, the correct matching code is A3, B1, C2, and D5. To wrap up our comprehensive look at India's geological history, remember these key points. India is shaped by 5 major physiographic divisions that dictate its natural resources. The underlying rock systems are classified into Archean, Purana, Dravidian, and Aryan eras. The ancient Archean rocks form the foundational basement complex, while the much later Gondwana rocks are crucial for holding 98% of the country's coal. Finally, the dramatic tectonic shifts of the Tertiary period birthed the Himalayas, ultimately shaping the Indian subcontinent we know today.